In this video, we're going to be answering the question, what causes John Travoltage to get zapped? And if you were working with the FET simulation, you can notice that you could rub his foot against the carpet and he starts to gain some electrons. This is going to be charging through friction, and we don't need to go through the details of it. We just need to know that he starts off negatively charged. And John Travoltage is a conductor. His skin is a conductor, his body's a conductor, and so that's why I have this material. It has the atoms that have the empty valence shells, so it allows electrons to move and spread out evenly. So John Travoltage is negatively charged. And then our other objects are going to be the doorknob, which is neutral, and it's also a conductor, which is why I have the background with the empty valence shells. And then the doorknob is also connected to the ground. And we can think of the ground as a relatively massive object, so it essentially has an infinite amount of electrons. So John Travoltage is negatively charged, and he's going to come over and touch, or even just get kind of close to the doorknob. Now, the general rule of nature is that nature likes to be chill, so if you have a lot of electrons here, they kind of want to even out. So automatically, these electrons, since they can travel through a conductor easily, are going to jump from John Travoltage to the doorknob. Now, in charging by contact, it would be kind of done right now, but since the conductor, the doorknob, is also connected to the ground, and this is an infinite supply of electrons, these electrons are going to continue to flow through the doorknob to the ground. So after this process has happened, John Travoltage is now neutral. The doorknob is now neutral, and even though the ground did gain some electrons, the ground is still going to be neutral. The reason being is because there's just so many electrons, even though it gained electrons. It's like adding a cup of water to a lake. You're really not going to see any difference in the water level. By adding the electrons from John Travoltage to the ground, you're really going to see no difference in charge of the ground.